Hello and welcome to the third part of a series of recorded walkthroughs of the United Kingdom Terminology Centre's Data Migration and Analytics Workbench. This is a proof of principle application written in Microsoft Access that demonstrates some of the properties and possible advanced uses of the data migration mapping products and of the terminologies that they link. The application is divided into four main areas of functionality: the console, which is displaying now, and the Browse, Query and EPR data sections. This walkthrough provides an overview of the third of these sections, the Queries tool, which can be opened from the button at bottom left. The Query, or Cluster Definition Editor, is an environment for creating, maintaining and testing query or report specifications in a range of different terminologies or classifications, and also for translating previously authored definitions between those terminologies and classifications. The user interface is divided into four panes, all currently empty, whose purpose will become clearer as the walkthrough proceeds. Across the top is a string of buttons which can be used to invoke various commands. In the center of the screen is a grey bar, which if we click on it can be dragged around to resize the various panes. If the Control button is held down whilst clicking and dragging, then a slightly different behavior is observed, which can be used to alter the size of the middle column. As with other interfaces in the Analytics Workbench, the up and down arrows in the center of the ribbon across the top can be used to increase and decrease the font size. And the cluster of option buttons to the right of the strip of buttons can be used to alter the lexical search properties. I'll start the walkthrough by loading in some previously authored cluster definitions. So I've just loaded in a number of definitions relating to the Quality and Outcomes framework, a payment by results scheme for UK primary care practitioners. For example, here we have a definition of the diagnostic codes to look for to determine the list of patients who have atrial fibrillation. And this list of codes is defined in two different terminologies, once in 5-byte read version 2, that's the RCT item here, but separately in clinical terms version 3. The 5-byte read version 2 definition appears as soon as I click on the cluster list on the left-hand side, and the definition appears in the clause list. So conceptually, a number of clauses make up the definition of a cluster, and for this particular read code cluster, there are only two clauses that make up the definition. The patient has the diagnosis of atrial fibrillation if their patient record contains either the code G573. Or any of its descendants, except the code G5731. If we click on one of the clauses, a hierarchy browser appears in the bottom window for the relevant terminology, and the items in green are those items which still remain in the cluster, they have not been excluded, and in grey, for example, is the item that has been excluded. If I click on an item in the bottom window in the hierarchy display, then the clauses in the top window that relate to that item will be highlighted. So for this item, it's only the G573. And all descendants clause that is relevant, whereas for the accepted item, we need to know first of all that it was included by this clause, and then it was explicitly excluded by the second clause. We can examine the definition of other clusters in the list by clicking on the appropriate items on the left-hand side. Here, for example, is the Clinical Terms version 3 definition of how to determine whether a patient has the diagnosis of asthma. And in this case, it's all the codes underneath H33 triple dot, with some exceptions, which I can visualize perhaps more easily by moving the bar in the middle. So we can see them as greyed out items in the list. As with other hierarchies in this tool, I can double click on items that are displayed to reveal their children. So, for example, if I double click on bisynosis, the hierarchy will refocus itself to show bisynosis as the focus concept and its immediate children displayed below it, and parents and ancestors above it. And the color coding is maintained. All of the descendants of bisynosis are excluded from this cluster because of this single clause at the top here. And again, if I click on an item in that list, I've clicked on flax dresser's disease, and the clauses in the upper window that have become highlighted are those which collectively have come to place it in the excluded state of being greyed out. In addition to importing previously authored cluster definitions and obviously creating new ones, which I'll demonstrate later, you can also save cluster definitions using the save icon, and then a number of options as to exactly what you want to save and whether certain things should be included or excluded appear. These are documented in the manual. To get rid of the save button, either click the cancel button, or if you click the save icon itself, the toggle will take the window away. At this point, it's worth noting that the cluster list window on the left-hand side is itself divided into two subparts: a read-only library section into which all external definitions can be imported, and a read and write editing section, currently empty. You're only able to change the definition of an existing cluster or create new clusters in the editing section. Clearly, however, it is desirable to be able to import an existing definition and then edit it. And in order to do that, we would need to select the item, click the copy button, and then paste it. And a little dialog comes up to say that the pasting has happened into the editing pane. If I OK that dialog and flip over to the editing window, we'll see that the cluster has been pasted into that window. It's also worth noting that the definition version has changed. In this window, the cluster that we just copied was version 22, and when it's pasted into the editing pane, it gets a different version number in anticipation of you then going on to change its definition. It's also possible to manually increase the version number of a loaded definition in the editing section using this button on the far right-hand end, which increments in steps of 1. A hidden feature of the copy button is that when I click copy, a human readable version of the definition of the text is pasted into the Windows clipboard, from where it can be pasted into any text editor or email client that you might wish to use to share the definition in human readable form. As well as being able to copy and paste between the library and the editing section, and also within the editing section to create a new version, I can obviously delete clusters using the delete button. And there's also a limited undo button. Certain actions, but not all of them, can be undone. So the delete option is not one of those that can be undone. Now we'll go on to creating a new cluster definition. And this time we'll do it in SNOMED. We need to give each cluster a unique name and specify which terminology or classification it's going to be authored in. And optionally, we can type some text. And when we've completed those fields, click New to create the definition, a blank definition, and then we can cancel, or again, the New Cluster button will toggle the dialog. If we want to change the properties, so in particular if we wanted to change the text or the name of a cluster, then click the Change button. But we're going to go right on ahead now and try and define a SNOMED encoded cluster definition of the diagnostic codes that would indicate a patient had atrial fibrillation. So we'll again make sure that it knows which of the definitions in the left we're going to edit. There's obviously only one, but we need to select it still. And now we're going to search for a string expression, searching SNOMED, using the lexical settings determined at the top little cluster of radio buttons here. The default settings which are showing here are usually reasonably appropriate. A complete coverage of what the other options and settings might mean is outside the scope of this walkthrough. But having asked it to search for this string here, we've got a series of results which we can click around in. So this demonstrates what the right-hand pane is for. And here we find atrial fibrillation at the top of the search list, and also now we've got it displaying in the hierarchy here. If I click on the item, that highlights it and grabs the code to the clipboard. And if I click the Add Clause button, the code that's in the clipboard will be pasted as a new cluster in the top window. We can now see that there are other codes in this list, which, because I've changed the definition by adding atrial fibrillation, are in fact now already explicitly included. So if I rerun the search query, the result set that comes back will be shorter than the first time round, because those codes which are already explicitly specified by the cluster definition as it currently stands will be suppressed from the result list. We need to make the font a little smaller so we can see the text on the right hand side, and maybe resize the middle pane. So we've got a series of atrial fibrillation diagnoses. Ventricular fibrillation is not a kind of atrial fibrillation. I'm not interested in statements that the patient's atrial fibrillation has resolved. I'm not interested that they have a history of atrial fibrillation if they don't have it now. And they might be interested in an electrocardiogram finding, so I'll add that. In fact, I don't need to click in this window. It's sufficient just to click on the item in the list on the right-hand side for the code to have been placed in the Windows paste buffer, ready to be added to the list at the top left. And here we have history of transient cerebral ischemia due to atrial fibrillation. I might decide to add that as a list. So I think that probably completes the diagnostic headings that indicate a patient has atrial fibrillation. But what if we wanted to capture that they were attending a clinic that monitored atrial fibrillation, but accidentally they don't have the diagnosis itself in their record? We'll see from the original cluster definition that a couple of clauses, exclusion clauses, were automatically injected at the beginning. This is partly because there has to be at least one clause in the definition all the time, otherwise the system will delete a completely empty clause. And partly because the three exclusion clauses are fairly commonly required, or at least if you don't want to exclude procedures, it makes sense to ask you to explicitly delete this clause. So if I wanted to look also for patients who had an entry in their record that they had had the procedure of monitoring their atrial fibrillation, I've got to get rid of this blanket exclusion of all procedures, because this is acting to suppress from the results set any procedure of any kind at all. So to delete a clause, click on this X button over here, and now if I rerun the search expression over the atrial fibrillation text here, we get more results, this time including some procedures. So, for example, we have referral to an atrial fibrillation clinic. Seems reasonable. If I'm going to refer them to one, they probably have atrial fibrillation. So perhaps that should be my definition. Or here we have provision of written information about atrial fibrillation. We want to soften our search to be less specific for those with an unambiguous diagnosis. We may wish to take in codes that strongly suggest the diagnosis of atrial fibrillation. Here we have they've been invited verbally for monitoring, and they've been sent letters. So the first letter of monitoring, second monitoring, so that was third, this is second. We'll just add the atrial fibrillation annual review concept for patients who have had their annual review for a diagnosis. And again, we can just click straight on the item to add it into the list of clauses defining the cluster in this window here. This central column here between the code and the term in the search result list gives a rough indication of how frequently the underlying clinical concept is encountered in a large data set of clinical records originating from UK primary care. The more ink there is basically in the symbol, that indicates that the code is more frequently encountered. So the hash symbol is used for the 1,000 or so clinical concepts which are most frequently encountered in UK primary care. The equal symbol are the slightly less frequently used codes. The minus sign indicates those fairly rarely encountered, and anything with no symbol at all is either exceedingly rarely encountered or never, although that may be due to the limited expressivity of the coding system used in UK primary care. I'm now going to delete the two exclusion clauses that were injected by the system as part of the blank cluster definition. But before I do that, I'm just going to show how the clauses are toggled between inclusion and exclusion clauses. So in this definition, we've got a number of trees or subtrees of the terminology that are all included, except the codes which are in the exclusion clauses. I can toggle something between inclusion and exclusion simply by clicking on the plus button here. Sorry, moved about. Put the event category back into the exclusion list, or I can put atrial fibrillation back in the exclusion list, and we can see that the ordering of the clauses is altered so that all of the exclusion clauses are gathered together at the end. In addition to toggling between inclusion and exclusion, we can also change the nature of the clause. At the moment, all the clauses that have been added have this double less than symbol, meaning the clause relates to this code and all of its descendants, even in those cases where there are no descendants in the terminology as it currently stands. So that's the default criteria that's used for a clause when it's added. But I may wish to say, actually, I don't intend it to be all of its descendants. I might wish it to be only the code itself and not also its descendants, as denoted by the equal symbol. I also saw going past the single less than symbol, meaning not this code but any descendants that it may have, of which at the moment there are none. So let's flip this back to all descendants again and go ahead and delete the other two exclusion clauses. This box is multi-select. You can either select one at a time or both of them together and then select delete to get rid of them all. The final part of the clause list management environment is the sort from A to Z button, which if I click it will resort the clusters, in this case alphabetically by the rubric, the term. This is the behavior for SNOMED and for clinical terms version 3, where the codes themselves are more or less meaningless. If this cluster had been defined in terms of the read codes, ICD or OPCS, the sort order would be alphabetical by code rather than by rubric. Having defined our cluster definition, it's possible to see the full list of codes implied by it by clicking on this button, the List Members button. This will produce a list of all the codes implied by the definition. So there's 10 clauses which collectively define 20 discrete SNOMED codes. The definition can, as we said, be exported using the export dialog, and we can select which schemes to export if there is a cluster definition for them. In this case, there is in fact only a SNOMED CT definition, so attempting to export clinical terms version 3 or read definition will produce an empty file. I can choose whether to export only the cluster definition as a concise piece of text, or only the list of members as a file, so this list over on the right hand side in a suitably formatted file. And if I export the cluster members, do I want the human readable terms with them, or any combination of those three? And if I export the cluster members, there are further filters that can be applied to force the exclusion of any members of the non-human subset, to exclude any members that are members of the former limited status subset used in the UK, and also to apply any of the standard search filters, these 4 items here, which also exclude certain categories of SNOMED content from either search results, or if this radio button is selected, also from the cluster member export list. So that more or less completes a description of the basic import, export, and create new cluster definitions. And so now we can move on to the more advanced functions of the workbench, beginning with the translate option. So here we have now our newly created cluster definition of the diagnostic codes within diagnostic and procedure codes, within SNOMED that would indicate a patient had the diagnosis of atrial fibrillation. And this is authored as a reference encoding in terms of SNOMED. But if we want to create translated encodings in different terminologies, we can use this button here. It brings up a dialog saying, well, what do you want to translate it to? The SNOMED option is grayed out because it would make no sense to translate from SNOMED to SNOMED. But I can select any of the other 4 terminologies that are loaded within the application and for which suitable cross-map tables exist. So if, for example, I click on the Read To button, it will go away for a little while and create a new Read To definition, which looks like this. And we could compare that either by eyeballing it with the one that we already had previously from the library. So here is the original definition in the read codes, and we can compare that one with the one we've just created, and we can see that there are some similarities. So the atrial fibrillation, atrial flutter concept is excluded in the translated version here. In the same way that I can generate a translation of the reference SNOMED encoding to clinical terms version 2, I can also generate a translation to clinical terms version 3. To ICD. Or OPCS, which is the UK's procedure classification. Although none of the procedures mentioned in the cluster definition have a corresponding OPCS code, and so there is no translation generated. But the ICD encoding, for example, says it's everything under atrial fibrillation and flutter, possibly these codes to do with the abnormal ECG we put in, or this pair of codes, G459 and I48, as an ICD expression, perhaps a dagger asterisk pair of codes, to say the co-occurrence of transient cerebral ischemic attack and also of atrial fibrillation at the same time in the same patient. To demonstrate the next piece of advanced functionality, I'm going to return to the library view. And here I'm going to load in an existing SNOMED subset definition from an RF1 release of the UK edition of SNOMED. It's a relatively small one, I'm going to replace the entire contents of the existing library with just the one imported subset. And here it is. So there's about 546 members of this subset, and the rf1 subset file has been imported as a list of all of the members, each of them with an equal sign. And as usual, we can click about to see where each of these sits within the hierarchy of SNOMED. And as we click about, we can see fairly clearly that very large parts of the family history tree are all lit up green. Pretty much every single member of this hierarchy is a member of the subset. And this suggests that although the current encoding of the subset is as a flat list of 546 individual members that all happened to be within the family history hierarchy of SNOMED at some prior point in time, it may be possible to re-express the definition of this cluster much more economically, perhaps as every single descendant of family history of disease. In order to do this manually and be sure that that really was the definition and that there were no accidental omissions or deliberate omissions would be rather slow and tedious. But the refactor command, this magic wand button, will do all that hard work for you. So if we click on that icon, the machine will go away and dream for a short period of time and come back with a compressed definition, an intentional definition that is valid for the membership of the subset as it was imported and the current version of SNOMED loaded into the tool at the moment. And it's worked out that those 546 cluster members would be regenerated from this particular definition if run against the loaded version of SNOMED. So as we suspected, we have pretty much every member of the family history with explicit context tree, but with some single exceptions under the procedure on family member hierarchy. To prove the point, we'll return to the original definition of the cluster from the library with its 546 clauses, and we'll change it a little before we refactor it. So I need to copy it. Takes a little longer because of the number of clauses, and paste an editable version into the editing pane. Still not quite there yet. So that's the concise version we created originally. Now we're going to take the unrefactored long list and make some random changes to it. So I'm going to scroll down randomly to the middle, highlight a number of clauses and delete them. And now I'm going to rerun the refactoring algorithm again and see what we get this time. So we've got substantially the same overall shape. We've still got pretty much everything underneath family history with explicit context. But we've now got some more exclusion clauses which relate to the concepts that I randomly deleted. So far we've looked at importing and exporting cluster definitions, creating new ones, and now refactoring them. The next part of the demonstration will look at maintenance of existing cluster definitions, particularly to take account of changes in SNOMED content that may have happened since the cluster definition was created. To demonstrate this, I'm going to load some more previously created cluster definitions that relate to infectious diseases. I'm going to replace the long family history subset in the library. So now we've got about 32 different clusters, each of them authored a couple of years ago, looking at trying to encode the sets of diagnoses that would indicate a patient had a statutory notifiable infectious disease. But because they have been authored a couple of years ago, many of them now contain references to codes which have become inactive in SNOMED content. So for example, the leprosy cluster I clicked on here has two codes at the top. They've been promoted to the top of the list: leprosy not otherwise specified and other leprosy. And in curly brackets is a statement that they're now limited status concepts, and they acquired this status in the 2011 April releases. Similarly, the malaria encoding has rather larger numbers. The avian malaria code, which was previously within the scope of the cluster, has been moved probably to the veterinary extension, and similarly the simian malaria code, and a couple of others have become limited, and the times or dates on which these status transitions occurred appears in curly brackets. If I click on one of these limited status items, the window on the right says it's an active code and lists the known suggested alternatives, which are retrieved from the SNOMED history mechanism statements. So in this case it's saying there's only one known substitute, 614620 malaria, which is in fact already a member of the cluster definition, so I could decide just to delete this item. Although since we're in the library view, this is a read-only version of the cluster, so maybe we should copy that one and a couple of other ones that we planned on maintaining across to the editing pane, where we can change them. So the malaria cluster is down here. Because we're in the editing section, it's actually offering to make any trivially definite substitutions for you. So I'll say, yes, you go ahead and fix what you can. And it says, okay, I found 5 clauses using an inactive code, and 3 of them I've managed to fix because fix is pretty unambiguous, and the remaining codes are still at the top of the list for you to deal with. On the right hand side, for information, are the substitutions that it's made. So it's saying that these 3 codes, the limited status codes that we saw previously, were in the definition and have been substituted, in fact, all with the same code. Malaria. These 2 codes have been left for us to deal with because there's no unambiguous automatic fix, or no fix can be determined from the history relationships in the relationships table of SNOMED. In this particular case, they both appear to be non-human concepts, so I could decide just to delete those completely from the definition as having been erroneously included in the first place. And now we're left with a cluster definition comprising around 38 clauses, and it's noticeable that this lot are all encoded as equals this concept and only this concept type of clauses. So perhaps we should refactor it to see what we get. And not surprisingly, we find it's every single code in the current edition of SNOMED below malaria, plus perhaps slightly curiously renal coccidosis had been included in the definition. So now we've had a look at loading, saving and exporting, copy and pasting, deleting individual cluster definitions, creating new ones, translating them between terminologies and classifications, and refactoring them. The final component of the cluster definition editor involves testing an existing cluster definition against real patient data. The demonstration environment has data from a real emergency department in relation to about 400,000 sequential attendances at the department, with a variety of presenting complaints, each of which was assigned a SNOMED code. Further information about how to load similar real patient data into the environment for local testing will be given in another part of the walkthroughs. Before I run the test, I'll just deselect the QT or query table option underneath. The function of this will be explained in the final step of this walkthrough. Clicking the button above runs the query definition that's currently selected, so in this case malaria, against the collection of patient records, 400,000 of them, also present in the environment. And if I select the Central Episodes option, I get a list of the individual time-stamped episodes of care, where on this date, this patient was assigned this diagnosis. And there's about 134 episodes out of the 400,000 presentations to the ED department. Alternatively, I can ask for the patient identifiers themselves, and if I click on these, I'll get the full patient record displayed in the hierarchy pane at the bottom left, color-coded blue for a man and pink for a lady. Alternatively, I can retrieve just the codes that have been encountered, so although the cluster as a whole will encode for 30 or 40 different flavors of malaria, in practice only 7 of them have ever been used within that particular ED department to encode malaria as a diagnosis, and the vast majority of those codes occurrences have used just one code, the parent malaria code itself. To demonstrate the function of adding the query table into testing cluster definitions against a patient record, I'm going to need to define a new cluster definition. So as usual, this blank cluster definition has been pre-populated with a number of exclusion clauses that we could remove if we wanted to include or search for procedures or events or whatever, but I'm going to just search for lower respiratory tract infections. And the one I want is probably this one here. Yep, lower respiratory tract infections. And I'm going to search the patient record repository for patients who have attended with a diagnosis of lower respiratory tract infection or any of its descendants. We'll just to speed look at the codes that we get back. And out of all the codes we could choose in here, the 400,000 odd attendances to the emergency department included apparently just over 1,500 that involve one of these diagnostic codes, mostly this code, lower respiratory tract infection itself, and there's a total of 29 codes within the scope of the cluster definition. But what this doesn't tell us is that some of the data had been entered into SNOMED at an earlier point in time when there was a code for recurrent chest infection and chest infections that were active at the time and had been put into the patient repository but are not returned by the standard query because these codes are now inactive and sit in a different part of the SNOMED taxonomy. In order to run the cluster definition to include these as well, it's possible to create an additional extra part of the standard transitive closure table, and the additional part is known as the query table, that adds in or repositions these rows that would put the concepts that are in the inactive space as though they were in the traditional taxonomy. And we can show the importance of this. If we include this additional part of the search element, we've now got nearly twice as many patients as we previously had, just under 4,000 now found with some kind of chest infection. 32 codes instead of the previous 29, so there's 2 codes that have been found now, including this one, which is now an ambiguous code. So there were nearly 1,500 patients who'd been given the diagnosis of chest infection before the SNOMED code with that preferred term was made inactive in 2009. So the query table can be used to correct for some of the inactivation consequences in SNOMED. And that concludes this demonstration of the query section of the Data Migration and Analytics Workbench. Thank you for watching.